Right, that's true. I'm recording. Yeah, good. Go ahead. Thank you.
Maybe I lost. Can you still see my screen?
Yes, yes.
Yeah, okay.
Yep.
I thought I lost it. So
Nope.
just first, to just go through RayStation in general, in case you're not familiar with RayStation, any of you. So RayStation is a complete treatment planning system with tools all the way from patient handling and patient modeling, tools for deformable and rigid registrations, and support for planning of all of the common external beam techniques. And now with the 10B that was released in Europe by the end of last year, it also includes support for high dose rate brachytherapy planning. And RayStation also has a very powerful toolbox for optimization, and also the possibility to evaluate your dose in different ways, and also to sum and deform doses. So I think it's good to know that this is just one application, and it's quite convenient to have just one system that you can use for both external beam and brachytherapy planning. For RayStation in general, we think it's important to provide tools that make it possible to automate your treatment planning as much as possible. And so that has also been one of our focus for adding functionality for brachytherapy planning. So there are a lot of tools for contouring based on deep learning and atlas state segmentations, for instance, that is useful, of course, also for brachytherapy planning. We have very good support for rigid and deformable registration and creating those automatically, and to see multiple images in a clear way at the same time. So more specifically for brachytherapy, we wanted the reconstruction of the channels to be as automatic as possible as well. So in particular, if you have a CT scan with really nice and clear channels, then it should be completely automatic. And then, as I said, optimization is a key strength, both in RayStation and in terms of expertise within the company. So we, of course, want that to be available also for dwell time optimization, and just for external beam to have the same easy configuration and the fast optimization times. And then we also have tools for templates and scripting, which really makes it possible to configure and customize your workflow in a really large possible ways. So that's like on the bigger picture. If we look more into details for applicator modeling, which is of course new as we're adding support for brachytherapy planning, we have tools to automatically reconstruct the applicator from CT data based on the image intensity. You can also, for your rigid applicators, you can define a predefined path in advance, the shape of the source path. And then while you plan, you just either click on a few points along the channels, or you rotate and translate it in the correct position. And this is like a generic format, so it should be possible to use for any applicator. And then you can, of course, also completely manually draw your channels and source paths.
May I ask a question, or should we do it afterwards? I just would like to ask about the generic format. Does it mean that the user defines the applicator on himself, or can we get this format somehow from the vendor of the applicators?
So the user can input that but then we can possibly share if you have one clinic that is using the same applicator as another, then we can transform it easily. But it's quite easy. We can show you afterwards how you define it. I mean, if you only define the source paths, it's just like a range of points that defines the line. So it's quite simple format.
Clarification was mostly regarding the vendors. They are providing applicator models. Can we import those models into the planning system? That was most probably the clarification we are looking for, correct? Vendor profile.
Yeah, so we're looking into that, because then I guess you mean also have the representation of the outer surface of the applicator.
Yeah, the whole thing, because the vendors, either Electa or Varian, they can provide the model of the applicator. And a few key points, it will generate the whole thing inside out, everything. Yeah, that we are looking for, or we are currently using.
Hey guys, sorry I joined you a little late, but we are looking at parasolids. So these are generated, they are, from SolidWorks or Pro-E kind of, I assume these are proprietary for the Electa or the Varian or however. I don't know if you have negotiated for them to bring those in, because it's not just the external surface, it actually models everything, the screws, the cavities. It's the most accurate way. And that would lead us for model-based those calculation algorithms. Eventually, we need those. Those were found to be the most accurate. A CT-based reconstruction is not as accurate. It has issues. If you look at TG186, task group 186 about it, you really can't describe those applicators, neither the composition of those. So just a heads up on how can you allow users to bring in these files in. You might want to negotiate that with the makers of these applicators.
And another related question I have, that you are mentioning about the CT image. How about MRI? Can we use MRI for planning?
Yes, so you can use either CT or MRI, but you will need the applicator models for the MRI often, right? But we're working on those 3D models, and we have looked at some.
And those computation.
Just a sample.
Okay, go
Sorry.
ahead.
So we looked.
Okay,
Okay, so we have received one example of an Electa applicator, just to see the format, and with some scripting, we were able to read the data and transform that into a geometry that we can then use to model the applicator. But I mean, there is some, you cannot directly import on the format that it is in Electa, but with some Python scripting, you can transform it to a format that we can then import into RayStation.
Yeah, and another question I was having, that your dose computation is based on TG236, or you are using any other algorithm like Monte Carlo or model-based computation?
So for the first version that is out now, we only have TG236, but we are looking into Monte Carlo-based dose computation for the future. So that's ongoing. Okay. Shall I
wanted to mention on the applicator modeling that we can import STL format files for through scripting. So if the vendors have those applicators in that format, we can do that currently.
Yeah, that is good, but I don't know that vendor to vendor, there any agreement you need that is beyond our user domain. That's why we don't know that part.
Yeah.
that is up to you to negotiate with other vendors whether you can integrate everything into one software. As a user, we are not able to suggest or do anything about that.
Mhm. So,
Yeah, thank you.
so and then all the tools for applicator reconstruction works on arbitrary image rotation, so you can align yourself with the channels. So with respect to dwell time optimization, once you have your applicator defined, you want to optimize the dwell time. And so we do have tools to specify your dwell times manually and scale. But we do see a big strength in our tools for inverse planning and optimization. So we have adapted our optimization tools that are used very successfully for our proton planning and adapted that for dwell time optimization. So you can configure it.
What approach do you take with the optimization?
I mean, it's a gradient-based optimization technique, which is the same as we use for our external beam and segment optimization. I don't think, is that enough?
Perhaps I can pitch in. So the proton planning, we have spot weights and spot size, but instead of spot weight, we call it dwell time, and instead of spot position, we call it dwell time. So it's the same kind of regime for the brachy planning as for proton planning. So the optimization engine is based on the proton planning. But of course, we have the limitation of the geometry in the patient.
So you can define your objective in terms of DVH limits, for instance, or max min dose values, or you can apply a dose fall off and some other. And like all our optimization, it's quite fast. So you can run an optimization in only a few seconds. And then you can, if you like, you can tune your weights a little bit to modify the plan. And the feedback that we have received from the clinics that has tested this has been really positive. So they have not, no one has done a big systematic comparison yet, but as they have tried on a few patients, they have been very happy about how they could easily create a plan with very good properties in terms of target coverage and organ sparing. And we've also seen that the resulting dwell times distribution are quite smooth. So another possibility with RayStation is for combined external beam and brachytherapy treatments. So first of all, you can plan them both in the same system, which is good on its own, but then you can do some more advanced evaluations if you like. So you can deform your external beam dose, if you like, onto the brachytherapy image set with the help of deformable registration. You can, with the help of scripting, compute the EQD2 dose. And then you can also sum those doses if you like.
Do you mind to share the deformable image registration behind the algorithm? Which algorithm you are using?
So it's, I mean, we haven't a specific deformable registration algorithm for brachy and external beam. So that's general functionality in RayStation, and I don't know the details. Maybe any
I can-
of the application
yeah.
specialists can.
Hi,
comment.
this is Freddie Cardell. And yeah, so RayStation has a few algorithms. One of them is called Anaconda, which is developed by RaySearch. It's our own algorithm. We also have Morpheus, which was developed with Princess Margaret Hospital, and that deals with sliding surface deformations as well. So we can certainly, if you're interested in the algorithms that we use, we can certainly send you more information afterwards if that's helpful.
Yes, if you can, after this meeting, share any literature using based upon the deformable imaging restoration, which algorithm based upon, then that will be beneficial. Thank you.
Sure. And what was the one before deformation? I couldn't hear that part.
I mean, I wonder is the B-splitting algorithm or other algorithm, and then how much they are different, and then based upon, I want to check the literature
Okay.
for their performance. So
Okay,
if
we
you
can
can share any literature related to your algorithm, that will be beneficial.
Yes, sir. No
Thank you.
worries.
Yeah, we also have an ongoing research project working with the deformable registration specifically for brachy and external beam. So we can also put you in contact with any one of those if you'd like. Okay, so now I will soon give over to David so that he can demo, but just to clarify what's included in the current release is support for high dose rate treatments. You can plan on either CT or MR or combined. You can reconstruct your channels automatically or manually. We have the TG43 dose computation, but for any source. So if you have the TG43 data, you can import it into RayPhysics and you can model that source. So it's possible both with the iridium and cobalt sources, for instance. We have the dwell time optimization. You can approve your plan, create the plan report, and create the DICOM exported plan. And that's the first introduction. So should we leave over to David, or
RaySearch don't have an own afterloader so far, so you have to model somehow and to characterize the afterloaders that are on the market. How do you do this in your program, and how do you connect to the afterloader itself? Will you cover this also?
I can say something about that briefly. So we started working with the BIABIG because they saw a common interest to have a treatment planning system that covers more treatment techniques. So we worked together with them to make sure that our plans can be delivered and to check with them what checks and requirements are made on the afterloader side. So that was very efficient and safe to work together with them. And then to model the other afterloaders, so if you use the TG43 dose algorithm, you just need the TG43 data for the source, and that is available. So you can model any source of the common afterloaders.
But what about the number of channels, the step size, and source strength, for example? So these technical parameters.
Yes. Yeah, so you configure these in our product RayPhysics, where you define your equipment. So there you define the number of channels, the step size, and we can show that to you, what you can configure in RayPhysics later.
Mm-hmm.
Yeah.
This is Zubir. I have a question regarding the previous slide where you stated that you can actually sum the external beam portion to the brachytherapy. How do you account for, you know, in brachytherapy, if, you know, with the gland being swollen versus external being, you know, the gland is pretty much smaller in the sense. How do you account for that?
Yeah, so we don't account for that. I mean, there is, of course, not that easy to deform accurately in some. And
Right,
so,
right. So
but
really, this, I'm sorry, go ahead.
yeah, so what you can do is you can transform your dose into EQD2 if you like. Then you can create the deformable registration and you deform that dose onto the other and then just sum them. So if that's a good enough model or not, that I'm not the right person to answer. Okay. So let's let David. Are you there, David?
Yes. Can you see me?
Yeah, can see your screen.
Yeah, we see your Zoom side. Yep, there it is.
There it is.
Yeah.
Awesome, guys. Very good. Everybody see me all right then, okay? So
Very
these
good.
awesome. So this is RayStation, and I'm just going to kind of go over you know, the general application. So it doesn't, I mean, this is how you would generally plan any patient in RayStation, external beam, protons, photons, whatever, Tomo, CyberKnife, you know, anything. So that is, you know, a big part of this is where you have one system. You have one system and you're able to utilize all of these tools within one system within here. So the, you know, we won't go over, you know, that much of the layout, but, you know, basically you're importing this exactly the same as you would a 3D plan or a VMAT. And as Elin said, you know, you have the options for contouring. You have 3 main auto type contouring. One is model-based segmentation. The other one is atlases. And then you have artificial intelligence or deep learning. So the skills that your clinic is using for everyday planning can be utilized within your brachy. So you're not exporting and doing some contouring in another system and bringing it in. There's a lot to be said about that. And also, you know, the deformable registration, your deformation, your image rigid registration, all is within the one system. So you're able to import all of that information within
I have
here.
a quick question.
Yes, sir.
Can I use your RayStation, the software for seed implant? LDS seed implant? Or
Not yet.
only for HDR?
Just for
No, not for
HDR,
LDR.
right? Currently is just HDR.
Okay.
Yeah. But if you look at our track record, we're actually, you know, we'll probably be on the road to be able to, you know, do anything that people would like. You know, we really, you know, make some changes quite quickly. So in here, you have, you know, you can contour, like I said, within here. Under your plan design, there's now a brachy planning module in here. Before, it was just plan setup, 3D, electrons, protons within here. You can add a plan. We'll just do HDR. This is the actual data set that you're going to compute the dose on. And then you have these afterloaders that I can show you there here. And then the application, the applicators that you have available. So in physics mode, as Elin was saying, is that where you can actually add this information. This is your general information, you know, number of channels, the diameter, the dwell time, step size, so forth. And then you actually have the source information that you can import, TG236. So then if you deprecate a source, you actually have that information within there also. And you have, you know, all of these different importable TG236 parameters at this time. Then you also have a commission application system where I could say, you know, I have an interstitial needles that I could actually implant, and it gives you, your radiated length, your outer diameter, and so forth of all of the application that you would have available. And these should be shared. So once somebody builds them, you should be able to share this information. Yeah, they would still have to commission it, but and approve it and say, yeah, this is what it is. But I believe that you should be able to share this amongst different clinics within the area there. So then you have a prescription, and this is very similar. If you guys are know RayStation, this is a very similar way that you plan within RayStation as far as a dose to a volume in here, and I can add that information. So you can see here now that you have a 3D type setting for your images in here. You have I'll turn off some of this external stuff, and I'll change the visualizations. I should have done this before, sorry. So you can see in here, you have all types of visualizations. We have these channels in here that are available, and I can translate or I can show these in a visualization in a rotation or a translation. So I could track that needle. So you can see here, as I scroll through this area, I'm actually able to manipulate the image so that I could track that needle. And I could do it in, the roll, pitch, or yaw in any type of plane whatsoever to be able to manipulate, to be able to see it. Now, I can detect, the system can automatically detect these if they're well defined. And it will go through here based off the density of each of the needles, and it will find that particular needle. And you can see it said it found 22. Now, yeah, it did find some outliers that's probably in the table that it did, but it will have to actually detect it. You can actually edit the tips and the bases and have it fill automatically for you. So you can manually adjust them if needed, or you could just build them if needed automatically. Now I have to identify, and this is how it kind of matches up with your HDR loader. So I can identify each one of these sources. So if I said that's 1, 2, 3, 4, 5, 7, here's your tandem, and here it is there. I missed one. There it is. So I would have to renumber that. So if I right mouse click, then it will eliminate the outliers that it found within that area there. And so you can see now I've identified each of these channels within the system there. Now I have objectives, and these are loaded as templates. Like Aileen said, you can actually utilize, a template if you have standardized things within your clinic. And this is typical for a RayStation to be able to, have standardized templates and functionality within the system. So if I add these in here, these are your objectives. And you can see here, I can have a min dose, I could have a uniform dose, EUDs, uniformity, within that area. And same way with your critical structures for that area. Under your settings here, you have the number of iterations that it's going to run, minimum dwell time, and maximum also within there. And for me, optimizing, this is on a laptop, guys. Okay, and so you can see how fast it is. There's nobody that's going to be able to utilize that. So the nice thing about this too is that, I could change this objective and just continue on. Okay, if I wanted to get more dose or less dose on the rectum, I can just change that objective and just say continue on, and it would change the dwell times and that it's in there. I can manually adjust those also. So if I wanted to say, okay, here, if you look here, and it shows you the source that you're on. Let me move this down a little bit. here it is right here. And I could go to this source and I could say increase that in seconds or decrease it by a percentage. Or I can take this paintbrush tool and I could say, okay, I need to pull this dose out of this area a little bit more. I can grab it on the fly and I can say, decrease the dose within that area. And you can see automatically while it'll optimize and change automatically. And then I can stop at any time. And the nice thing about RayStation is always you have the ability to undo and redo so that you could always go back a step if you didn't like what it did, or you could redo. Now, the other nice thing is evaluating this dose. Okay, I can use a simple DVH. I can use dose statistics, D99, 95. I can turn, these on here. It'll show you 95 average dose, D50, whatever you want there. The other thing is clinical goals. Now I can have clinical goals. This is your scorecard, guys. Okay, so I can go in here and I could add a physical goal in here for my bladder, and I can say average dose, dose to a volume, volume dose, conformality index, homogeneity index, and then I can prioritize that too. I could actually do it to a point also. I'm actually able to add a point in here. And so I can create a point here. I can move it around if you're doing like GYN applicators, like fleshers and stuff like that. You can do point A, point B for the future within there. The nice thing is that I can scale the dose based off of this all within here, or I can do a reduce organ at risk. So these are all tools that are generally used in RayStation as an external beam that we've incorporated into the Brachy module also, where if I didn't push the organ OARs hard enough, the system can do it for you automatically. So that's extremely powerful there. How are we doing? Questions?
Yes, this is Zubir.
Yep.
2 questions. So when you're using the dose brush,
yes, sir.
Obviously, it affects the optimization that you have actually done. And number 2, the second question is that for the dose brush itself, how is it actually activating as you start to pull? Is that
the diameter of the circle? Yeah, the diameter of the circle. Mm-hmm.
Can I finish the question?
Sorry.
Is it using any of the dwell points that are in the area, and what's the rule on that one?
So it's using the dose distribution based off the circle. See the circle in that diameter of how many vertices superior and inferior that it's affecting. So it's just, I think it's doing kind of the weighting of each of those. Is that correct, Dylan?
Not sure
I
I
think
understood that.
I think it runs an optimization to get the same dose as you have, but with a lower dose within the sphere, and as much lower as you pull. But I really think that with the optimization, you shouldn't need it.
I understand. I guess the point here is that we always don't recommend too much of graphical optimization, which is your dose brush here. And that's why I'm raising that point.
Yeah, I think it's our dose brush has the same sort of, it can have the same kind of effect.
Yeah. Anybody else? Any other questions, guys?
Yeah, about the hardware a little bit. Two questions. One about the hardware. Do you have customers from all or using all types of afterloaders? So Varian, Electra, and Baby on the market already. And I would be interested if you can show a kind of treatment report or dose planning report.
So regarding the question about the afterloader, so we currently have support for BABIG, and we're working. So we have quite a number of our customers that are using Elekta equipment. So that's what we are focusing on now to make sure we can get that connection to the afterloader to work, and to make sure we can plan for that. So.
Okay, here's a plan report. Yeah.
So this is what it will look like. This
okay.
is, yeah. And this can be customized any which way that you guys specify what you want to see in it. Okay.
Yeah.
Yeah.
Is this linked to the afterloader in one direction only or bi-directional? So give the afterloader a feedback if the treatment was successful.
No, we don't have that feedback yet.
Okay, I have a couple of questions. First of all, if I want to do second check using another software, right, like RadCalc or similar, it can be exported to RadCalc to do the second check of the computation.
So it'd be DICOM exported.
DICOM export, okay. And another thing is that like LINAC, when you do external beam, we transfer the plan to the record and verifying system, for example, ARIA or Mosaic. Is it HDR part also integrated through those type of record and verifying system, or is it just send the plan to the treatment delivery unit and treat there and record it manually?
Yeah, so far we have only done the direct import to the afterloader. We are discussing how to integrate with through our own OIS RayCare for the future.
Okay. And is this HDR planning system FDA approved, or you are still in the process of getting the approval from FDA or European regulatory authority?
So we're approved in Europe, and the FDA approval is in progress, and we're hoping to have it by this summer.
Oh, okay. Okay. Thank you.
It's version 10D, correct? Yeah.
Can I ask, there's a difference in how the different, the Varian, the Elekta, and the BIVIC, does their markers, as far as whether the markers are supposed to be designating the first possible dwell position or the very tip of the source wire. Do you have a way of your own that you do that, or do you accommodate whichever device is being used for the delivery?
Yes, so this is a property that you can define in Ray Physics for your applicators, where you want the reconstruction to start from. So you can choose between a central distal most source position, inner lumen end, or applicator tip.
Thank you.
So just a follow up from Bruce's question, you don't have it set up to avoid an error that once the system arrives at the institution, it's set up as a quote unquote a variant system per se. So that way people don't make the mistake with that typical first dwell point. Or can that error be committed basically?
I'll jump in on, no, we don't prevent that error from being committed. It's up to the physicist on site.
But you have templates, right? You in your physics module, you have for each
Correct. You would
loader.
We have clear diagrams that show the tip position and the diagram of the source when you enter in your TG43 data. So it's fairly clear how to define your source.
Do you mind
we have-
further explaining that use case as you were pointing out? Maybe the question isn't clear. The use case again, as far as what the mistake could be, or how would you define it?
Maybe David, if you could pull up the ray physics to that source definition diagram. Yeah, right here. And scroll down to the picture.
Here, or do you want the
Oh, on
applicator?
the application.
The applicator.
There we go.
So we give fairly clear directions on what dimension is what.
And as the basis for this, we use the DICOM recommendation for how you should define the different properties.
I guess for this example case for Elekta source, correct?
Why do you say that?
This
Because
should be generic.
The center of distal most source position.
Oh, you mean that in their table? Yeah, right. Yeah.
Can you show how you define the geometry of an applicator?
Yeah.
So if I now buy a new applicator, a new cylinder or ring applicator, you mentioned in the first type part of the presentation that the user can model it on himself.
Yeah, I will see if I can demonstrate.
sorry, if you do not mind, can you quick show? Oh, it's already done. Can you quick show the variant source diagram too?
I'm sorry, we don't have a specific variant source diagram.
Oh, okay, thank you.
Yeah, okay, so if you have a predefined, if you want to use a new applicator and you know the shape, so either you can use this predefined path if you only define the source path.
Mm-hmm.
And then you can just click on points and then you can rotate and translate that in the correct place. But then you can also, if you want to have the full applicator model, so you can, in different ways, you can create regions of interest, either by importing an SDL file if you have it, so if you have that from the applicator manufacturer. So I have one here that's from Elekta that I could, with some scripting, import, and then I can create what we call in RayStation a structure template. So I can take this here, I select it, and then I can use either a rigid registration if I have an image set that where these are positioned correctly, or I can just align image centers. So then you will get something like this. So this is the outer structure, and then inside you have the source paths.
Okay.
So the source paths, you can define them. They are just like locational points along this that you can rotate and translate.
Mhm.
And then there are generic formats on how you represent the surface like this.
Mm.
So with some scripting, you can it should be possible to get applicator models that are given as an XML file or an open format like that.
Okay, thank you. Nice. Yeah.
Thank you.
Any other questions, guys?
On what she was just explaining a second ago, the source track, sort of like, I'm just trying to think whether it would be very helpful to, with some, like with an arrow or something, showing where the first and last point will be along the applicator, activation points. In other words, if it's done in the reverse way, per se, could that be caught? And there was actually one case that occurred just like that. It was a medical event. I'm just curious.
Actually, there's been more than one.
So I mean, you can see in the patient views where the distalmost dwell point is. So you could verify, if you know where it's supposed to be, you could verify that's where it turns up in the system. But I don't know if that would be enough.
Also looking at the dwell times or looking at the dwell positions with the visualization of the added, like if you pulled out of David, like if you're looking at the applicator and if you click on the dwell point, that shows up on the visualization of that. So that would be another indicator if you're doing a check that by clicking on the dwell time, that you would be able to also look at where that that position is on the patient view or like the 3D view or your axial views.
I guess probably I'll ask you another question that will determine whether that would actually happen, is that you only have one way, and that is either from the endpoint, in other words, distal or proximal. You don't have both options. Am I correct on the reconstruction?
Oh,
You can
defining the
start.
path there. Yeah, go ahead, Dan.
Yes. So you only have one direction. People can't, by mistake. Is that correct?
So you mean if you want to reconstruct from starting from the other side?
Correct. Yeah.
Yeah, you can start from the other side, and then there's this tool flip that flips it, and it's indicated. The tips are pointy in the visualization, and the ends are like funnel shaped. Maybe you can show it, David.
But when you are creating it automatically you are reconstructing the applicator. By default, it starts from the tip, or you can choose it, tip end or upper loader end, which end.
I guess the graphic shows that blue and tells you how that was reconstructed.
Mm-hmm.
Yeah,
no,
and you can
when
then
it is done automatically, how it is selecting which end to start.
I mean, when you do the fully automatic, it will take the highest up in the body will be the starting point. But then you can flip them, and you can flip them all at one time if you would like to have it in the other direction. But since it's more common that it's the tip is highest up in the patient, that's what you will get. So you cannot configure it, but it's very easy to flip direction.
So if you have an endobronchial and you have it find the applicator, does it think it's going in from the bottom?
I really have no experience with that. Does anyone else from the
Yeah,
team?
yeah, I would think yes. Yeah, so if you're doing an endobronchial, it's going to, the automatic channel detection is going to start at the nasal,
But you have the option to flip it though.
and then you'd flip it. That'd be part of your workflow.
It'd be nice to have only one way that the user can basically disable the other option, and then that way there is no, mishap and go in the opposite direction.
Well, sometimes you want to go. I mean, we have cases where it's a lot easier to go from a template on the perineum.
Right, I
Very
agree with
easy to
that.
go from the tip.
Yeah, I agree. Okay, well, sorry guys, I have to leave. I have to go to another call.
Thank you for your
Thank
time.
you.
Thank you
Yes.
for your joining, Zubir.
I wanted to circle back on one of the questions that were asked before about swelling, and I'm assuming you're talking about like HDR prostates and stuff like that. So we do have the ability to re-image and then do a deformation, but we could actually replan on the new image set to see what's going on, and if you have to deform and map structures and map everything over, we can do that as well. We are also looking at, it is not in the system yet, but we are looking at adding robustness, which is in standard RayStation for photons and protons. But I think that would also be a good solution for you if you have an idea of basic swelling of the gland. You could always put that in the future. So that's something that's coming. So I just wanted to make sure that I brought that up.
What do you mean by robustness?
So when robustness means that you could actually plan and define what you feel there may be motion. You could do setup error. You can do any kind of motion that you believe. It's nice if you actually have the image sets that show the motion, like a 4D. So then you could actually do a 4D optimization across all the images. But when it comes to robust optimization, if you don't have the 4D, you can say, I'm going to, RayStation, I want you to understand that this gland may swell or it may move in XYZ, pitch roll, any direction that you think this may happen. And the optimization will be based on assuming that it has moved, so that if the structure does move or does swell, it's covered. We also have a robust evaluation tool, which you can actually go in and try it out and say, there are, if this thing grows or if this moves in certain directions, will I still cover it? And then you can put clinical goals and say how much is still covering. So David's actually showing how you can create a simulated organ motion. So if you only have the one data set and you're just assuming that the prostate might move or grow and stuff like that, you could actually simulate it, and it creates a data set with this motion, and then you could plan on it using 4D optimization as well. So there are a lot of little tools in here that you can certainly verify motion or growth or shrinkage in RayStation, and then evaluate. David, could you just quickly show the plan eval, like the robust tab?
Do you mind to, I know it's a proton and external beam, the optimization or accounting for the uncertainty, which we call the robustness optimization, has been lots of literature. But for HDR, do you happen to have any literature
No.
for that approach?
No, not yet. It's something that we're looking at adding. It's not even in RayStation yet, but this is something
Okay.
that I don't know, Emil or Eileen, if you want to, talk about what's in the works or what we're planning to do.
Yeah. Yeah, so I had one last slide to to what we're working on currently and in the near future. So first one, like we mentioned before, we have validate with BIABIG, and now we are working on ensuring interoperability on most common afterloaders. So we're starting with Electa's afterloaders because that's what most of our RayStation users are using. And I show you the full 3D applicator models. We're finalizing that to include also the outer geometry and to make sure there is a way to transfer external applicator libraries into RayStation. We're also looking into adding like so that you can, without scripting, compute your EQD2 doses and evaluate in terms of EQD2, and also take that EQD2 dose and deform it and sum it if you would like. And then we're also working on adding the possibility of Monte Carlo dose computations. And then we work continuously with our partner clinics to further improve, of course. So that's what our focus is for the near future.
And then we'll hand it off to you, and then you guys can write some cool papers, right?
That's right. A lot of cool tools, coming from protons and photon world. We definitely will be interested in the Monte Carlo as well to see how that's, although you're right, TG43 is still the most, it's still the standard. So, but it's good to have that. Don't stop, now working on it. Do you know when this might happen? The Monte Carlo dose engine?
We're working on it. We'll probably quite soon have a prototype, but then there's a big job to validate it carefully, of course.
Yeah.
But we're working on it.
Can I ask you gentlemen a question?
Sure.
If you were building a brachy planning system, what would be your top 10? What do you guys want to see in a program like this? And shoot for the moon. Tell me what is the best thing, or what you would like to see that's different than what's out there, or what would make life easier? Because these suggestions are great for us to actually try to get this stuff in there for you.
So in my opinion, a modern algorithm is quite important. So not only TG43, that's the first step, is good. And then if you now look for Monte Carlo or something in this direction, that would be good. And it should be quick or fast, so not waiting half an hour until the computation is done. That would be good. And we are using a lot of adaptive planning in our hospital, using ultrasound also. So using frame rubber cards or direct DICOM inputs working with live images. And this in this regard would be quite important for our clinic.
I can elaborate. I can follow. This is the sort of if you guys do not have an applicator and afterloading unit, this is a sort of the third-party treatment planning system. So these can cover, I'm not sure the Zoft still electronic brachytherapy source, but their side, they do not have a treatment planning system. So these can cover even electronic brachytherapy source, which is very critical for the heterogeneity corrected dose calculation. So that need to be included. That's the one thing. Another component is this is the depends on the app. Since you guys do not have app loading unit, depends on the app loading unit and the applicator and source relationship, which is can be the end of the internal lumen or some gaps, safety margin, and then so it depends on all those. The user, if they use the wrong marker, and then just manually define the whatever bright signal on the screen in your system, that can be easily systematic more than 1 millimeter, 3%. So it's easily more than 10% error systematically can happen. So there is another secure layer. So once the user identify which vendor, which applicator is used, then the planning, the reconstruction algorithm or the way of reconstruction need to be correlated so that to minimize the user's misadministration. That component, I think, worthwhile to put your effort and then close collaboration with the related company, applicator company as like a BBIC or the other brachytherapy major vendor. So that is my comment and recommendation.
Also, in this regard, I would like to think about that you also can think about LDR, especially seed implant, that is also in on software can handle everything. That will be helpful to have so that people don't buy multiple software. It is sometimes difficult as well as for a physicist. We need to learn so many different software, how to handle it. Those types of things can be avoided. And on top of that, if you can have the dose computation with model based or Monte Carlo, that may be helpful. And do you have any timeline when you expect that this particular module will be approved by the FDA? I mean,
we're aiming for this summer.
Yeah, summer with TG236, guys. So I mean, and that's version 10B. I have RayStation clinically for photons. I use it and have a version 10A. So so I assume all of this would be available by September clinically.
And the proton planning system is already approved?
Oh yeah, it's been approved
Oh,
since
yeah.
2012.
Yeah,
Okay.
that's they started there first. Yep.
Yeah, and that's full month.
Particular proton machine, or it is more generic, you can include any proton machine into your system?
Yeah, and we're actually even the sole. I believe we're the sole TPS for some of the Mevion systems as well, the Hyperscan. So yeah, we support them. We do carbon. If you guys ever are interested in that too, you know, and we do some. We also have a program called Micro RayStation for small animals, and there's even some helium out there. So yeah, no, we certainly do a lot of cool things, but. Right now, we're trying to break out the brachy. We are very hopeful that 10B was in FDA's hands right now. So it's been a couple of months. So we're hoping within the next month we can get a release on it. But I'm still curious to hear more. Give me more, guys. What do you want?
Are you extending it to the flash therapy?
Mukim, we are, aren't we? Or Sam? I thought
Yeah,
we were. Yes.
we have a group that's
Yeah.
evaluating flash therapy. Absolutely.
Yeah.
Okay. And as you mentioned that your contouring system can take that the AI approach or deep learning.
Oh, absolutely. Yeah.
Is it only for contouring, or you are expanding it to other areas like?
We're doing planning as well. We have auto
planning
process. Yeah, so we're using machine learning for we do deep learning with for auto segmentation. So we have head and neck, thoracic, pelvic models, and then as far as the planning portion, we've had models for prostate, We're getting into head and neck, as well as we're doing breast auto planning using machine learning and deep learning. And we currently, I think we're going to release it soon, doing auto planning for protons as well. So yeah, it's a very active machine learning group that we have, a team that's working on a lot of those AI products.
No.
And that was approved. I mean, some of our deep learning auto segmentation back a couple of years. So it's on like the 4th iteration. So we released it in version 8B, and I think others on the call had mentioned that we're currently on 10A, and 10B is the release. So we've sort of been improving that AI algorithm for 4 iterations now.
Do you
So
have
it's very robust.
any available literature or white paper on this AI-based planning or contouring? Anything?
Yeah, we can definitely provide that for you.
That will be great if you can share that published literature or whatever you have.
Sure.
We'll learn more about it.
Absolutely. We can get that to you.
Thank you.
Thank you.
You're welcome. I have a couple more questions. You kind of mentioned seeds and LDR and stuff. How important are the other modalities of brachytherapy to to the entire group? And I know that this isn't just the U.S. Am I correct? We have Europe here as well.
Mm-hmm.
So I would love to hear how important do you think seed implant pre and post and LDR is to you guys?
Anybody has the seed implant program can answer the question.
Yeah, it is very important because thing is that if you see the scientific result or the clinical outcome, still it is attractive for different reasons. But all over the world, if you see, it is difficult sometimes to get a good plan or shortage of well-trained manpower. That's why if you are approaching the deep learning based or inverse planning or more optimization, that may help a lot of people to continue this procedure, as well as bringing some new folks into the group who was less training or less experience. That's why though HD are getting popularity, but most probably LDR or seed implant is not going away. That is the thing. It will stay, or some places it may be more attractive for different reasons.
Especially prostate. If you guys, depend on what market you're targeting, but GYN, HDRs definitely, but your prostate LDR implantations, you should have that, because I mean, look at we use that real-time treatment planning in the OR, which means you do have to have it on a laptop, right? So you're gonna have to you have to be able to connect to real-time ultrasound, to download images and plan in the OR. So think about like a transportable RayStation, a mini RayStation on a laptop.
That wouldn't be a problem for us. That would be we would definitely be able to do it on Citrix and have a laptop in the OR remotely connect. That wouldn't be an issue at all. What's even more interesting is the ultrasound. That's something that we should do as well. And I'm assuming like the EQD2 stuff you would want in planning in order to do really good composite plans between.
I don't use too much of. I do have a spreadsheet which is very simpler. ABS has a biological VED kind of, we do, but we haven't really tapped into that. I have Ray biology in my RayStation, but I don't honestly, like say with CyberKnife, I don't necessarily convert things. I should, but I just don't. I don't know in brachytherapy, they don't do sophisticated biological models yet. I think we feel like there's not enough data to really support any of it. It's just it's okay to do that simple stuff, but not. I mean, voxel-based BED calculation is kind of, there's a lot of research need to be done. It seems there's a gap of information.
Sure.
So I wouldn't put my all resources in that. I would more enable ultrasound based. I mean, look at what MIM is doing. They actually created a LDR TPS in there. I mean, they're Fusion software, right? I mean, company, but they chose to do for prostate. They targeted that because they have very nice fusion algorithms between ultrasound and CT or MR, where other companies didn't have that. So that's their strength. And it's, by the way, those engine there is TG43. I don't think you're going to be able to do Monte Carlo based. Your cross section, I mean, your data out of, because of the low energy is going to be much trickier. But people are, I mean, they're developing these planning systems, but nothing commercial, right, guys? I don't think anything for LDR using model-based dose calculation engine is available yet.
I don't think so.
No, because the uncertainties of the cross-section data, what you're going to put in, so the composition of your tissue is tricky to extract from CT.
When you talked about using Citrix with your ultrasound in the operating room, how much would that slow down the process?
None.
That's...
No, there won't be any slowdown. You know, it's. I would say the majority of RayStation customers use the Citrix setup, and we even have the Providence network out west that it's from California Arizona all the way up to Alaska, using similar servers. So there wouldn't be anything as long as the whatever PC that you're using in the OR is connected to the network of the hospital. You shouldn't have any problems.
I just want to also follow up on that question about the auto segmentation. We actually have a customer who is working on creating deep learning models for HDR, specifically for gynecological cases. So just to, the idea of speeding things up and doing that. So yeah.
So definitely speed efficiencies. If you could demonstrate that, that's key for HDR. Any minute saved is a minute earned in patient.
Correct, and that's why these customers are working on creating deep learning models for the contouring steps for the HDR. Even though there's not many contours, but like you said, any seconds or minutes gained is a huge advantage to the clinic, and so that's what they're working on.
Right.
Actually, last I heard, it's $200 a minute that you would save.
Oh.
Just one comment is the OAR rectum bladder sigmoid is not the physician or user dependent, but the HRCTV is really user dependent. So my comment is if the user can train their own data and then modify the deep learning based segmentation algorithm based upon their own physician's data, that will be beneficial. Otherwise, one clinics based upon some physicians contouring based auto segmentation may not work for the other clinic. If the segmentation only limited to OAR, in that case, I recommend to test for CT and MRI. So trained for both ways, so user can use the selectively for both cases. Thank you. Bruce, do you have any other final recommendation or comment for RayStation?
No, I think you all have had pretty good comments. I think the system has thought of a lot of the things that are necessary. It'll become more obvious as more people use it.
Thank you.
Yeah, and I'm glad they are joining the ABS. This is right, Freddie. This is the first time you guys coming to the ABS meeting in June.
Yes.
So that's good to kind of, introduce it to the physicians, and it's great to be working with TG236. We are, as you know, we are in draft mode of a task group. So we don't talk, and we do talk about, that's why we kind of thought inviting you about so make you aware of our initiatives. And on the AAPM, I think you guys could see our, what is the objectives of this. So we're glad that you're working on this and bringing advances in other modalities into brachytherapy. We encourage innovations and people who are really dedicated to these kind of things. So great product. I think it will. I mean, I think it's, as you say, it needs to be worked into the clinic and figuring things out, but you're pretty close to at least starting something.
I agree.
Yeah, thank you again, and thank you for putting this together, because we truly value your comments and your suggestions. You know what? I'm so sorry, I didn't even turn on my camera. Hi. So we value your opinions, and when I saw your email, I reached out to everybody and said, hey, this is something we really need to do, because you're the voice, and you guys are the idea guys, and that's why I wanted to know what you guys wanted, because I think it's very important that development here at RaySearch hears what you guys are saying. I mean, it's I'm a clinical guy, right, Ferris? You've known me a long time,
Yeah.
and it's one of those things where I and that's why Mukeem and Sam and Emil and even Peter here and David, we're all clinical folks, so we want to hear what you have to say, because we want to build the best product, no doubt, but we also want to make sure that we're solving problems. I mean, nobody wants to create another brachy planning system, that's just going to do the A to Z with no, let's make it better. And the fact that you guys talked about ML, deep learning, and all this other cool stuff, live ultrasounds. I mean, that's awesome stuff. And that's stuff we certainly want to get ahead of and get it out there for you guys, and appreciate your time as always.
Great, and feel free, if you guys want to circle back on the group, to call us, with an update if you guys in the future. I mean, we'll see how long this task group, maybe, I don't know, Bruce, do you know our timeline? Is it another year? Hopefully we will get to it. I've lost track of where we are on it, but the goal here is to have it comprehensive guidelines. You could probably use some of that at some point.
Yeah, no, that'd be great. We could set something up, Aline, after the release, and when we're coming up with the new release, we can do something like this again and show you what we're working on, get your input, because again, it's very important to us that we do this right.
Yeah.
Okay, sounds good.
Very good.
I have one last question, because when you went through, it was really interesting to get your feedback, but no one mentioned the PDR. How much do you use pulse dose rate?
There's only one system. I commissioned it at MD Anderson. I have 4 PDR units. I'm not aware, maybe one in Canada, that's it.
Okay.
So
that's not something we should focus on.
For the most part, the theory was that they would give you the benefit of HDR and LDR. And it turns out more or less that they give you the problems of HDR and LDR more.
Yes, I had the privilege to be the physicist on call, and I would be called at 2 in the morning on a Saturday, and my wife hated me for about 6 years. And I was, but I was very impressed. Wow, I'm getting on call and I have to figure things out. Yes, PDR is only for people who have a lot of resources, and these are shrinking these days. So maybe Europe, maybe they still believe for head and neck cancers, they still believe the continuous dose rate. It's a simulated continuous dose rate, as you know, but it's everything here in the United States, probably you would think high dose rate has taken over. I don't think you guys should really invest too much, at least in this market, with that.
Yeah.
What I would think
Thanks.
invest in is alpha particles. That's where you need.
Mm-hmm. Right.
And Bruce could tell you all about it. So we've been trying, you know.
Not on
So,
this call.
yes, another one. So
Okay.
we'll pick his brain on things we were trying to do with that. So it's really innovative stuff. So
Excellent. Well, thank
all
you
right,
guys.
Freddie. Well, thank you very much for setting up this and taking your time.
Yeah.
I know we went over a little bit, but it's very, I think the group is very, it's funny that nobody really, when I mentioned it to the committee, they said, what are you talking about? This is, you know, this is how new this is, you know, so.
No, this is great. This is great.
Yeah.
So when we have updates, you know, who's my lead? Is it still you for us?
Sure, yeah, you could reach me.
Okay.
Or you, Song, you know, I mean, any one of us, just reach out, say, hey, we have updates. We'd like to schedule a meeting and give you a demonstration that to keep the committee, because we are forming now our consensus. Basically, we're saying this is how, where the certainties, uncertainties, what to do. And it's good to know your tools and what's up, because I don't think we've even, you know, scratched the surface on any of these aspects of machine learning in Brachy. But we should maybe have a section there for future developments and where the field. Of course, I mean, the task group has been in development for several years now, and doesn't mean we won't have a part 2 update in the future, and say in 5 years when things are settled and we have enough research on these items, we will update the recommendations. But keep in mind, it's very critical. As you know, AAPM and task groups is that's how we do things. That's how things become, you know, standard of practice, is by that consensus. So it's a very important group for you, I think. And that's why I thought about you immediately to say, be aware you should be collaborating with us. We have other vendors who are aware of our products. So our activities. So we want you to be also as much have the same access to the members. So
Yeah, no,
Would
we-
appreciate it.
yes,
Absolutely.
definitely. Good job.
Thank you.
And then we'll definitely be sharing those items that we talked about, right? The ML white papers and things like that. So we'll definitely
Thank you.
upload that stuff for you too. So, yeah.
All right.
Great.
Thanks, guys. And give us an update when, you know, as the TG236 moves along, and because we had some of the information that we were looking at, and again, if there's anything you guys want to see or you know, touch base on, or you need more explanations with, just shoot us an email and we'd be happy to do a quick webinar and show you. My cat's about to go across the screen. I'm sorry, but the perils of working from home. But appreciate your time again. Thank you so much.
Thank you.
Okay,
Thank you.
Thank you, guys.
Thank
All
you.
right.
Bye. Thank you.
Bye-bye.
Have a good
Bye-bye.
afternoon.
Good time.
Thank you.
Take
Take
care.
care.
Thank you. Bye bye.
Thank you.
Take care. Bye-bye.
Bye.
Bruce,
Bye.
can I talk with you? Oh, he already left. Okay. Bye bye. Thank you.